बिल्लाहि मिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अल्लाहुम्मा अफ़्तह अलैना हिकमतक वअंशुर अलैना रहमतक या ज़ल जलाली वल इकराम अल्लाहुम्मा इन्नी असअलुका इल्मन नाफ़िअन व अमलन मुतक़ब्बलन व रिज़्क़न तय्यिबा अल्लाहुम्मा आफ़िनी फ़ी बदनी अल्लाहुम्मा आफ़िनी फ़ी समई अल्लाहुम्मा आफ़िनी फ़ी बसरी ला इलाहा इल्ला अंता सुब्हानका इन्नी कुन्तु मिनज़ ज़ालिमीन रब्बि ज़िदनी इल्मा रब्बि ज़िदनी इल्मा रब्बि ज़िदनी इल्मा। Assalamu alaikum everyone. Okay, now today we are going to start method of error detection. So we have covered this objective, understand the need to check for errors after data transmission and how these errors can occur. Describe the process involved in each of the following error detection method for detecting errors in data after transmission: parity check, even parity and odd parity we have discussed yesterday. Checksum and echo check, they are left, but there is a problem when we face a problem in which we are not able to detect errors with the help of parity check. So how you will figure out that it is correct data or not? So for this purpose we will use parity block. This was the reason we have done this exercise yesterday. Now, if two of the bit change value following that transmission, it may be possible to locate the error using parity check. There is the reason. Let us imagine we are transmitting the following byte. This information we are transmitting from computer A. So we are applying even parity over here. So let's count even number of ones. Only ones, not 0. 1, 2, 3, 4. So we put as a parity bit 0. We have even parity. Let's send this. Suppose more than one bit has been modified during the data transmission. More than one bit has been modified during the data transmission. This means that a byte could have reached the destination as of any of the following. For example, this bit has changed, and this bit has been changed. These two bits has been changed. 0 turn into 1 and 0 turn into 1 over here. These two bits are changed now. But look here, 1, 2, 3, 4, 5, 6. But it retained the even parity. It's following the protocol retaining the even parity. We have sent even parity 1, 2, 3, 4, and here data has been changed during data transmission, but it will retain the even parity 1, 2, 3, 4, 5, and 6. So, for example, now 2 bit has been changed, 1 bits are changed, this one and this one, and then here this one and this one. But it will retain the even parity. Look here, 1, 2, even parity, fine. Because even parity we have applied, and there is an agreement between sender and receiver. When we will encrypt or decrypt the data, we will apply even parity. Encrypt meaning making data meaningless, and decrypt mean to get the data into its original form. So look here, 1, 2, 3, 4. Again, it's even parity. Now, in all these cases, the byte has clearly been corrupted, but the byte have retained even parity. Data has been corrupted during the data transmission, but it will retain even parity. Therefore, no error would be flagged. In spite of obvious error in the transmission, clearly it will be necessary to have other ways to complement parity. Even it comes to error checking to ensure errors are never missed. One such method is called, because with the help of even parity or odd parity we are not able to identify error, then we will go for the another method to ensure that data arrive at destination without any error. So one such method is called checksum. This is our next topic, but you should have concluded that any of the bits in question 2 could have been changed where there was a transmission error. Therefore, even though an error has been flagged, it is impossible to know exactly which bit is in error. We cannot identify because they are retaining the even parity. We cannot identify with the help of parity check which bit has been changed during this data transmission. To overcome these issues, there is a one way which is known as the parity block. One way around this problem is to use parity block. In this method, a block of data is sent. A block of data is sent and the number of 1 bits are totaled horizontally and vertically. In other words, parity check is done in both horizontal and vertical direction. As the following example show, this method not only identify that an error has occurred but also indicates where the error is. So we can easily identify errors and identify which bit or byte has been corrupted or changed, and we can identify and we can correct that error very easily with the help of parity block. Now let's check in this example how to apply this parity block to identify the error. In this example, 9 bits of data have been transmitted. So we have the 9 bits over here, 1 byte, 2, 3, 4, 5, 6, 7, 8, 9, and then parity byte has also added over here. Okay, now an agreement has been made that even parity will be used. We will use from computer A and computer B. For example, my computer and your computer, they both use what? Even parity. Another byte known as parity byte has also been sent. This byte consists entirely of the parity bits produced by the vertical parity check. This parity byte also indicates the end of block of data. This parity byte shows that this is the end of block of data. This is the end of the block of data. Okay. Now, shows how the data arrived at the receiving end. It is also necessary to check the parity of each byte horizontally. Byte 1 to 9, from byte 1 to 9 horizontally. We first check the data like that, in the horizontal direction like that. And after that, we will check the data vertically to identify byte number and the bit number like that. First step, and this one is our second step. So let's apply this formula over here. Let's apply this method. So we are applying even parity. So let's check first horizontally. 1, 2, 3, 4, 5, 6. 6 is even. Yeah, this one byte has been transmitted correctly and received correctly, no error. Byte number 2, 1, 2, 3, 4, pass. 1, 2, 3 and 4, even parity. Again, byte number 3, let's check. 1, 2, 3, 4, 5 and 6, even parity applied. This one is clear. Now byte number 4, 1 and 2, even parity. Now byte number 5, 1, 2, 3, 4, clear. Byte number 6, 1, 2, even parity, clear. Byte number 7, 1, 2, 3, 4, 5, 6, clear. Byte number 8, we have 1, 2, 3, oh, now odd parity, because we have agreed we are going to send and receive even parity. So look here, byte number 8, there is error over here. Byte number 8, we will note down this byte. Byte number 8, we are having error. And now let's check byte number 9. 1, 2, pass. Okay, now 1, 2, 3, 4, parity byte. Okay, pass. Okay, now byte number 8 located. Now let's check vertically now. 1, 2, 3, 4, 5, 6, clear. Okay, now even parity. Now let's check here over here. Bit 2, 1, 2, 3 and 4, no error. 1, 2, 3, 4, even parity applied. Okay, now 1, 2, 3, 4, 5, 6, even parity. we are calculating only once. Now bit number 5. So what we have over here? 1, 2, 3, 4, 5. So error is over here. It is error because it's no odd parity applied. So byte number 8 and bit number 5. So we write over here bit small number bit 8 and byte number 8. So error located here. We will later on we convert this 1 into 0 to correct the error. So let's find other. So error is over here bit 5. Now 1 2 3 4, no error, clear. 1 2 3 4 5 6, even parity, no error. 1 2 3 4, no error, even parity. So we have successfully located. So where is the error? Error is our in byte number 8 and bit number 5. We just need to change this 1 into 0 to correct the. First we have located the error in our data transmission, and later on we can identify, locate it, and then we will remove this error. Okay, now we have successfully located the error. A careful study of table 2.3 shows the following: byte number 8, row 8, byte 8 and row 8 has incorrect parity. There are 3 ones, 1, 2 and 3 bits. Bit number 5 we have located over here, bit 5, column 5 also now has incorrect parity. There are 1 bits, 1 2 3 4 and 5. First of all, the table shows an error has occurred following data transmission. 3 there has been a change in the parity in one of the byte. Secondly, at the intersection of row 8 and column 5, so here is the intersection of row 8 byte and column number 5. Here is the intersection common point of the incorrect bit. Intersection of row 8 and column 5, the position of the incorrect bit value which caused the error can be found. The one bit at the intersection should be 0. This means that the byte 8 should have been this value right now 1 and 2, now it converted into even parity, which would also correct column number 5, giving an even vertical parity now has 4 bit ones. The byte therefore be corrected automatically as shown above, or an error message could be relate back to the sender, asking them to retransmit the block of data. So look here, we will convert this 1 into 0. So now let's count 1 2 3 4. Now we are 4 ones over here, even parity, 1 2 3 and 4. And now in this row we are having how many ones? 1 and 2, even parity. So both are now corrected. That's all. With the help of Parity Block, you can remove the error. Now activity 2.6, question number 1 and question number 2 is now your classwork. Do it now. Then I will give you answer. We will discuss later on. Come on class, do it. Activity 2.6. Please start.